Okay, so we have been talking about our domain and range of our functions, and now we're going to continue to add to our vocabulary. So now we're dealing with zeros of functions. And I'm going to kind of skip the definition real quick and go down because there's other vocabulary words that you're going to hear. And those vocabulary words are root, the x-intercept, and solution. So again, all about the context and what they're asking you, making sure that you are using the situation given to understand what the question is asking you. So your definition of a zeros of function. So graphically, so this is going to be from your graphing calculator or an image that's given to you. So graphically, it's the points at which the graph intersects. And we're talking about where it intersects on the x-axis. So we talked a lot already about the y-intercept. Now we're talking about basically the x-intercept. Algebraically, so this is when you're given like an equation or your function. The points, so depending, there might be one, there might be two, sometimes there might be more than two, depending on the type of function. So algebraically, it's the points for which f of x is going to equal 0. And let me remind you, we have mentioned this before, but I just want to remind you, f of x is basically a fancy way of saying, what is your y? Okay, so we have basically two situations here. Okay, so when you cross your x-axis, your y value has to be 0. So that's your algebraic, and that goes back with your graphic, your graph image, sorry. So given a graph, so this is one way of determining your zeros of function. So given a graph, you're going to highlight or mark your x-axis, and then wherever this line crosses, this is going to be your x-intercept. So in this case, it's going to be 1, 2. So x is going to equal 2. Now I'm going to leave some of these blank so you can try to do some on your own as well. So I'm going to work on the odd numbers, and then you can work on the even numbers, and then I'll show you the answers for those at the end of the video. All right, now if I have a circle, remember you're going to want to pay attention because it's going to hit possibly more than once depending on where it's on the x-axis. So right here, it hits here and it hits here. So your x's this time could actually, your x-intercepts this time could be -3 and +4. All right, and then number 5 down here at the bottom, this one actually does come across the x-axis again as well. So we have a point here and a point here. So our x in this case could be a -1 or a +4. So in this case, you have two roots, two x-intercepts. All right, so I want you to go ahead. I want you to pause it. I want you to work through 2, 4, and 6. And then I want you to come back. Okay, so here are your answers for 2, 4, and 6. Notice how number 6 actually has 3. Okay, now moving on to the back, algebraically. So again, we've already talked about the graphing, and now we are going to work it out by hand. So step 1, you are going to set the function equal to 0. again, your y is going to equal 0. Your f of x will equal 0, which essentially means your y will equal 0. So when you do that, you are solving for x. So y, you're going to take out your y and you're going to replace your 0. So 0 equals 4x minus 8. And you solve this just like you would if it was a regular equation. You add your 8. 8 equals 4x. Divide by 4. And that would give you 2 equals x. So your final answer, x could be 2. Okay, so again, we're going to take out our y. We're going to put a 0. We're going to solve. Please do not ever leave your variable with a negative coefficient. You're going to divide by -1 because remember there's that value in front that doesn't have to be there. So 7 equals x, which is your final answer. So as of right now, we only have one x-intercept for these. Okay, 0 equals 1/2 x plus 2. Subtract your 2 from both sides. Again, I'm just treating it like a regular equation. I'm solving for x. All right, and then I'm going to divide by 1/2, which essentially means I'm multiplying by the reciprocal. All right, so -2 times 2, -4. I don't need the 1 under because it doesn't change any of the value. Anything divided by 1 is going to be itself. Okay, again, I want you to stop. I want you to practice 2, 4, and 6. Okay, and here are your answers for 2, 4, and 6. Double check the work. If you have any questions, please just ask. And don't forget your integer rules. A negative times a negative is a positive. A negative times a positive is a negative. All right, now the next section. This one is going to be a little bit trickier with my video. So with that being said, I would like you to plug this into the calculator, and that's really all you're doing. So the next section, what you're going to do is you are literally going to open up your graphing calculator, and in your spots, you're going to hit y equals, and then you're going to type in whatever function it is. And then step 2, you're going to hit the graph to view the graph, but most of the time it just pops up. So, and what I mean by that is you are going to take out this x of x and you're going to put y. So when you enter this into the calculator, it's y equals x squared minus 16. So when you look at the graph, you're going to realize that it actually looks like a hill. It's going down, up, down. I forget which one this one was. So when you are looking at this one, I believe this one goes down and then back up. So when you are double checking your x-axis, wherever it hits is going to be your x-intercept. So in this case, you should be hitting on the line at -4 and +4. And we will learn more about the factoring part, so you'll get into it mathematically later on in the school year, but right now you literally are just typing it into the calculator and seeing where it hits on the graph. So with number 3, again, y equals, type in exactly what you see. And if you typed it in correctly, you should be hitting on the x-axis at -6 and +4. Now, I'm going to stop there just because, I mean, honestly, you really are just entering things into the calculator, which is fine, and it should not take you that long either. So I'm going to ask that you pause the video and come back and just verify your answers at the end. Okay, so you should have taken some time, typed it into your calculator. Now, if you recognize we have some functions that have 2 x-intercepts, some have 3, and some actually get into 4 intercepts, x-intercepts, which means they're hitting the x-axis 4 different times. There is a practice assignment after this, so if you would please grab it. It's homework 4, zeros of functions. When you are done, you can check with a neighbor. You can check with the answer key. And again, let me reinforce. The videos are here because you can keep rewatching it to understand, and you can pause it and come ask questions. Okay? So good luck, take your time, and please put this on page 48, please. 48. So that way you have your reference notes page. All right. Thank you so much. Take your time.